now going to calculate the cross product, sometimes called the vector product, using Cartesian components. And in this particular instance, I'm just going to look at when we multiply I, j and k together. So let's go back to our definition of what the cross product is. A cross B is equal to the magnitude of vector A, magnitude of vector B, sine theta, where theta is the angle between A and B, times a unit vector that is perpendicular to both A and B. And we'll call that vector n, unit vector n. All right, so what happens if we just have a look at unit vector I times unit vector j? Using the definition, it'll be the magnitude of I, magnitude of j, sine, now the angle between I and j is a unit vector out in the x direction, which is I, and the j is a unit vector out in the y direction. The angle between I and j is 90 degrees. Now let's give some meaning to this vector n. We want a vector that's perpendicular to both I and j, and the way to work out the direction of that vector is to place your hand with your fingers pointing in the direction of the first vector, which is vector I. So your hand would be there, fingers pointing out that direction. Curl your fingers towards the second vector. So your fingers would curl around. Your thumb then would point straight out of the page. Since I can't draw that, I'll do a 3D perspective like that, and that's vector k as we know it. So this is our normal I, j and k. It is perpendicular to j, and it is also perpendicular to the I vector. So this will be times k. K is a unit vector, so we'll just put it like that. So the magnitude of vector I is 1 times sine of 90. If we go back to our unit circle, which has a radius of 1, 90 degrees is up here. The coordinates of that point are 0, 1 if we've got a unit circle, and we know from previous work that this sine is the y coordinate. The y coordinate here is 1, so that'll be times 1 times unit vector k. We'll put our little, and 1 times 1 times 1 is 1, so we just get vector k. Okay, so I cross with j gives us k. A way to remember that is to simply put I, j and k down, and we draw, if you like, a circle going in this direction, and we go in the clockwise direction. So anytime we do a cross product, we put them down in the clockwise, we'll get the positive. So I, j will get k. If we did j crossed with I, if we did that, when we put our hand down to work out the direction, it would actually be going into the page or up in that direction. So it would be the same length, but it would be minus k. So when we go, how does that tie up with our little diagram here? When we go around this way, so we go anti-clockwise, we get the negative. So if we start at j and then go to I, we'll get negative k. Likewise, you can combine these in lots and lots of ways. So if we did k cross with j, okay, we're starting here. We go to j, and we'll get, let's go again, we go k cross with j, so we're going to get an I, but we want to know whether it's positive or negative. Which way are we going? We're going in the anti-clockwise direction, k, j, so it'll be negative I. Okay, so you can start anywhere in that circle, and whether you're going clockwise, if you go clockwise you'll get a positive answer, and if you go anti-clockwise you'll get a negative answer.